We mixed all the reactions together. These are called double displacement reactions, by the way, because two things get replaced. So let's start with these two compounds. This is called silver 1 nitrate. This is +1. We look on our periodic table, look up silver. We look on our reference table, we'll find that nitrate is -1. And since silver is a transition element, we have to give it a special name, and that's the Roman numeral indicating the charge. Here we have sodium iodide, the typical binary compound, meaning it has two elements in it, sodium and iodine. End it with IDE. Sodium is +1, iodine is -1. So what really happens here? I put an AQ there. AQ means aqueous, it's dissolved in water. What happens then is water will come in here and dissociate this. It splits it. It splits it into Ag plus NO3 minus ions. Same thing happens here. So we have sodium plus and iodine minus ion, and they're all aqueous now. This plus and minus, which was together, now we're divided by water. That plus, if we put all these together, that plus could find its way to that minus, and that's exactly what happened. We get AgI, and what's left over? Na and NO3. We always put the positive one first. So Na plus and NO3 minus. This is aqueous. We need to figure out which one of those is the precipitate. Nitrate never forms a precipitate. It always is soluble in water. So sodium nitrate is going to be soluble in water. That means this is our precipitate. We put a down arrow. This is called the ionic equation. We made it ionic here. We could keep writing and we'd say that AgI is the precipitate, and then Na would be separated from NO3 minus. All ions. Then we have what's called the net ionic equation. What produced our precipitate? And in this case, that precipitate was yellow. Right there, solid. It was Ag plus the I gave us AgI. If we want to name these, this is silver +1, so use Roman numeral 1, iodine. And this would be sodium nitrate. Here's your net ionic equation, meaning this is really what happened. We saw the yellow precipitate. What's left over? They're called the spectator ions, just like spectating fans in a sports arena. What's left was Na plus, nitrate minus. Sodium ion, they weren't part of the reaction. They just were carriers, if you will.